In this video, I want to show you how to use your calculator to quickly and easily do permutations and combinations. I'll be using some examples taken from section 5.5, starting on page 313 in the text, so you may want to go there if you have your book with you. Whenever you're confronted by problems that you know involve permutations or combinations, it's important to decide whether you need to use a permutation or a combination. How are you supposed to know? Well, I think one good way is to ask yourself whether or not the order of selection matters. If the order of selection is important, then you're probably using a permutation. If the order of selection is unimportant, then you're probably using a combination. As you can see on page 308 in the text, a combination of n objects taken r at once is really a permutation of n objects taken r at once divided by the number of ways to order r objects, in other words r factorial. You can see that right in the center of page 308. So basically a combination is a permutation with the order divided out. Now for the first example, I'm going to look at page 313 here. I want to do problem number 48. Number 48 says, forming a committee. 4 members from a 50-person committee are to be selected randomly to serve as the chairperson, the vice chair, the secretary, and the treasurer. The first person selected is the chair, the second the vice chair, and so on. How many different leadership structures are possible? Now in this problem, they're clearly telling us that the order of selection matters. So this is a permutation. And there are 2 ways to approach this. You could do this from a fundamental counting principle perspective, in which you have 4 slots. And for the first slot, you have 50 choices. And once you've selected, then you have 49 choices for the next slot, and then 48 choices for the next slot, and then 47 choices for the last slot. So there's the number of ways right there. And that's not a bad way to calculate it, but there's a better way. And that would be using the built-in permutation function that the calculator has. To use that approach, you first key in 50, and you go to the Math menu, and you go to the Probability submenu, and you can see choice number 2 right here is n objects permuted r at a time, NPR. And that's the one we want. So you'd select number 2, you put in the number of objects that we're permuting, press enter, and you can see that we get the same result. Here's a different problem. I'm looking at number 54 on page 314. The problem says, children. A family has 8 children. If this family has exactly 3 boys, how many different birth and gender orders are possible? Now they explicitly say birth and gender orders. They don't ask you to name the kids or anything like that. So I think it's pretty clear for this problem that the order of selection does not matter, and this is a combination. So there's actually 2 ways to calculate this as well. Actually 3 if you want to go with a fundamental counting principle, but that would be a very tedious way because it would require you to enumerate very many different computations, as you'll see. So definitely we want to use the built-in combination function from the calculator here. And first we'd key in the 8. And you can visualize this problem as you have 8 slots, and you want to fill 3 of the slots with boys. So how many ways can you do that? Well, that would be 8 choose 3. And so to use the built-in choose function, you also go to the Math menu, go to the Probability submenu, and you can see that number 3 here is NCR, that is n objects combined r at a time, or n choose r, as some say. Anyway, you put number 3 to take that, and then you want to put in the 3 for the number of boys. And so you can see that there are 56 ways to do that. Now you could also compute that using the number of ways to arrange the girls. And the slick way to calculate that, instead of going back to the Math menu, would be as follows. You can just go second enter. And this recycles the most recent key press that you've put in. In fact, you can go back several key presses if you want to. But this is the easy way to do this. And so you could just go back to the 3 right there and change it to a 5. That's the number of girls. And press enter, and you can see you get the same result. There are often parallels like that in choosing. If you want to see a little bit more insight into that, you could go on the internet and you could look up Pascal's triangle and see how Pascal's triangle connects with the choose function.